Hello guys, welcome to DTW Tutorials. Welcome. Alright, if this is your first time on this channel, DTW Tutorials is an educational channel that supports students in their WAEC, that's your WATS, your BEC, your JAM, post-UME, NECO, junior WAEC, name it, in their maths and also in their physics. Okay, if it's your first time, please try to just click the subscribe button down here there just to support this ministry. And if you like what we're doing, give this video a thumbs up and also share this video with your friends, family and your colleagues. Okay, so we support students in their education. So today we're going to be taking a look at resistors in parallel. I've done already a video on resistors in series. You can check that out. Okay, so now this is the resistors in parallel. So I'm going to explain everything about it now. So now you have an electric circuit here. Now we have three resistors connected in what parallel. Now there are three things to note about a parallel connection. Now the first thing is that the resistors are placed side by side. You can see they are placed side by side. Okay, so first thing, it is placed side by side, meaning this is the negative, this is the positive, this is the negative, positive, this is the negative, positive, where each negative will be connected together and each positive will be connected together. You can see there are differences between resistors in series and parallel. I'm still going to do a video to explain that difference, okay, in a practical way. So we have this. The first thing to note is what? Side by side. The second thing to note is that the voltage that flows through each resistor in parallel is the same. So we have what? Same voltage. That's the second thing to note. The voltage that flows through R1, R2, R3. This is the voltage, that's the power source, is what? The same. Now the third thing to note is that the current that flows through R1, R2, R3 is what? Different. Okay, you can see when the total current come in here, it is what? Splitted into what? Three parts. That's R1 goes to R2, R1, I2 goes to R2, I3 goes to what? R3. Okay, so it is what? Different. So different currents will flow through resistors arranged in parallel. If you use your ammeter in your laboratory, you will find out that different currents will be measured in this resistor 1, 2 and 3, while the same voltage will flow across these resistors, the same voltage. So number 3 is what? Different currents. Okay, so these are the three things to note in resistors in parallel. Now to get our equivalent resistance, since I is being shared by the three resistors, so we have to look for the total I. Now total I, remember from Ohm's law, V is equal to what? IR. Therefore I will be equal to what? V over R. I hope we remember our formula, subject of the formula. So I is what? V over R. So to get your total I, it will be what? V1 over R1 plus V2 over R2 plus V3 over R3. And we know that V is the same, okay? That is V1 is equal to V2 equal to what? V3, which is equal to V, okay? Since the same voltage will flow across the three resistors. So from here, we can just bring out a big letter V, and we have left in the bracket 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so here what do we have? Now we can easily cancel out. Okay, we can cancel out V, since this is V over R. So when we cancel out, we're left with 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the formula to get our equivalent resistance in a parallel circuit. Okay, that's resistors arranged in parallel. To get your equivalent resistance, you perform this. That's the ratio of reciprocal of each of the resistors. Okay, so this is how you get the total equivalent resistance of a circuit in parallel. So things to note: in resistors arranged in parallel. One, they are arranged side by side, that's placed side by side, all negatives connected together, all positive connected together. And two, the same voltage flows through across R1, the same voltage will flow across R2, and the same voltage will flow across R3. That's your total voltage will flow across each one of the resistors. Okay, and three, different current. Okay, you can see the current coming in and branching out to the different resistors. So this is all about resistors in parallel. In our next video, as I promised, I'm going to give the difference, show you the practical difference of resistors in series and in parallel, and also there will be a video where we're going to take a project, a real life project. We're going to build an extension box project upon the principle of resistors in parallel. All right. One more thing to show is that apart from this arrangement, the resistors can be arranged this way also, where you have also your negative, positive, negative, negative, your positive and positive here, and you see them arranged side by side. Okay, so when you see circuit like this, don't get confused. This is also resistors in parallel, not series, because I notice most students get confused. They're only used to this particular arrangement and not used to this. Okay, so this is also resistors arranged in parallel. You can see your current coming in and different current flowing through the resistors, while the same voltage would flow across each individual resistors. All right, thank you for staying tuned to today's video. See you in our next video. You are destined to win, and don't forget, Jesus Christ is coming soon. Give your life to Christ. Bye.